Hey there! In this video we are going to use graphing technology to identify information and features of graphs of quadratic functions given their standard form equations. So we're going to use some graphing technology to create the graph for a quadratic function and then use that graph to determine some of the important features and information about that function. Now there's a whole variety of graphing apps and software that you could use. Two of the ones that I use all the time are Geogebra and Desmos. Both of those you'll find easily just by searching online. You can use them online, or you can download the apps for your computer or your phone for the two of those things. For this one, I am going to use Desmos to generate the graph. So we're going to do that right now. So we can start by putting in our function, y equals 2x squared plus 7x minus 30. And then we can look at the graph. We can see some of the graph, but we can't see enough of the graph to get all of the important information that we want. So we're going to have to change the dimensions of the grid here so that we can see more of the graph. Now, just like any other app, if you're using a touch screen computer or a phone, you can just put your fingers on the screen and then move them farther apart or closer together to zoom in or zoom out. Now the problem with that though here, like if you zoom out enough to see where the vertex and the intercepts are, the thing is so skinny that you got most of the screen is blank there. So what would be better to do is you can change just one dimension at a time. You can change the vertical or the horizontal separately. And the way you do that with a touchscreen is you just put your fingers on the axis. So if I put them on the y-axis, it turns blue, and then I can squish it vertically. So I'm kind of zooming out one dimension, but I'm keeping the other dimension about the same, because then when I do that, I can get to about there where I can see all of the important points, but I haven't kind of compressed it sideways. Now the thing is though that you recognize the way the grid is here, one square horizontally doesn't mean the same as one square vertically, right? Like each step here is 5 vertically, but now it's still 1 horizontally. If you wanted to change it horizontally, you could do the same thing, grab the x-axis and move it out or in to do that. If you're working with a non-touch screen thing, if you're working with a computer, you hold the shift key and then you get the axis turns blue and you can move it that way, or you can do it vertically like that, all right? And then working with Desmos is pretty easy because you can just click on the important points. Like there's your vertex, there's your y-intercept, and here are your two x-intercepts. And so you have those values. Now we'll take a screenshot of this and we'll go back to the other document and write down some of the important information. Now we can use our graph to write down some of the information. Our vertex was negative 1.75. Negative 36.125. Our direction of opening was up. Our axis of symmetry, right down the middle there, is going to be related to that number there. It is going to be x equals negative 1.75. Our max-min value, this has a minimum value. It has this low number. That is the lowest it goes. That is the minimum value. So we're going to say it has a minimum of negative 36.125. The y-intercept was that number there. We can write it again as coordinates of a point, or you can just write it as negative 30 like that. Now while we're thinking about y-intercept, you might have in your work with quadratics already recognized the relationship with this, and in standard form that value of that constant term, they are indeed going to be the same. You will see that more and more as you continue to work with things. The x-intercepts, 2 of them, we had negative 6 and 2.5. Again, you could write them as points if you want. The domain is going to be all real numbers, as we've seen with quadratic functions. And then our range is going to be related to our minimum value here, and the fact that the thing opens up, it is going to be that y has to be greater than or equal to negative 36.125. All right, let's do another one. All right, so like last time, we'll start by putting our function in, which was y equals negative 0.7 x squared plus 4 x plus 21. And like before, we can't see the whole graph. We can see even less of it this time. We can see just this one part of one side of it. So we need to change things around here. So what I'm going to do is I'm going to move it to the left here, and then I can see both parts here, both x-intercepts. And you can kind of tell by this, it sort of curves the way it's sloping there, that the vertex is going to be up above. I want to see that. So I'm not just going to move it down, because then I'm going to lose the x-axis here, right there. So instead what I'm going to do is I'm going to change the vertical scale. So kind of compress that down like that, and then we can see more of it there, right? We can do this a bit if we want, so we can make sure to see everything. And we'll put it about right there, and then you can click on those points, the x-intercepts, there's those two, and the y-intercept and the vertex. All right, so again, we'll take a screenshot of that and get some of our important information. All right, so again, we're going to use our graph and the points we found to determine some of our information. Maybe the first thing that's important to recognize here, with Desmos, it only goes to a certain accuracy that's displayed on the screen. And so if all of your points are 4 or 5 decimals like that, probably what it is those are approximate values. It might have calculated more, but we're going to assume those are sort of approximate values. So from a vertex, I'm actually just going to write down and say that it is approximately 2 point, maybe I'll even just do 3 decimals here, 2.857, 2.857, and 26.714. And then, of course, the direction of opening is down. Our axis of symmetry, this line right here, related to that x coordinate there. So we're going to say that x is approximately, use the approximately equal to sign, 2.857. This thing has a maximum value because it opens down. So there's a top to the thing. The top is related to that maximum value of that y value there. So we're going to say this has a max of, I'm going to say approximately, right? Because it's not exact, 26.714. Our y-intercept there, you're going to find that is actually exactly equal to that. Again, you may have noticed, but the connection between the constant term and that y-intercept there, it is actually 21. So I'm going to say it's just 21 here. Our two x-intercepts, however, are most certainly approximate. Again, at this point, there's not really a way of knowing for sure. Your future learning with quadratics will help you with that. But right now, I am just going to say that it's approximately. We'll write that first one down, negative 3.32. If we're doing it to 3 decimals, we're going to say 321 because the 05 is going to round that up, the 0 up to a 1. And this one is going to be 0.35. So we're going to say 9.035. You can write more accuracy if you want. And our domain again here is all real numbers. You might tire of writing that so often. And for our range, well, that maximum value and below is what we're looking at. What we really want to say is that it's less than or equal to this approximate value here. So what you can say is you can say y is less than, instead of saying equal to here, what you can do is you can put one squiggly line. Now this might not be a symbol you've ever seen before, but that means less than or approximately equal to negative 26.714. You do sometimes see this symbol with 2, but just to be consistent with what we use for less than or equal to, usually that's the better one to do. All right, so that's that information from that function. All right, and that's it. That's graphing quadratic functions with technology, resizing the graph as necessary, and getting information from that graph.